take a look at these numbers. Can you tell which number is larger? The answer is neither. Both of these numbers have the same value. One is expressed in standard notation. The other is shown in scientific notation. Representing a number in scientific notation doesn't change the value of the number, just the way it looks when it's written out. For example, the speed of light is 300 million meters per second. But we can also show the speed of light as 3.0 times 10 to the power of 8 meters per second. It's the same value either way. When a value is represented in scientific notation, the first element is known as the coefficient. The coefficient can be any number greater than 1 and less than 10. The second element is known as the base. In scientific notation, that number will always be 10. And that third element is called the exponent, or power. Scientific notation allows scientists, mathematicians, and you to write numbers and measurements that are very big or very small in a simpler way. Think about these measurements. The circumference of the Earth is about 40 million meters. That's a lot of zeros to write. It's much simpler to work with this value as 4.0 times 10 to the power of 7 meters. The Sun has a mass of 1.988 times 10 to the power of 30 kilograms. Scientific notation allows very large or very small numbers to be added, subtracted, multiplied, or divided without a lot of zeros, which can easily get confused or incorrectly recorded. Let's take a look at the rules that must be followed in order to express a number in proper scientific notation. The coefficient must be a number between 1 and 10. The coefficient must be multiplied by a power of 10. You will see that the coefficient must include or imply a decimal point. Depending on the number of significant figures, you might represent a number as 3 times 10 to the power of 2 or 3.0 times 10 to the power of 2. The exponent can be either positive or negative. The exponent changes according to how many places to the right or left you move the decimal point. Moving the decimal point to the left will increase the exponent. Moving the decimal point to the right will decrease the exponent. Changing a number from scientific notation to standard notation, or from standard notation to scientific notation, is as simple as moving the decimal. Let's look at the area of the Pacific Ocean, which is 6.378 times 10 to the power of 7 square miles. The exponent is positive 7, so you know the number in standard notation will be much greater than 1. You will move the decimal 7 places to the right. Now we can see that the Pacific Ocean is 63,780,000 square miles when written in standard notation. What if you want to switch from standard notation into scientific notation? The process is the reverse of what we just saw. Take your measurement and move the decimal point as many positions as needed to arrive at a number between 1 and 10. The number of times you moved the decimal will be the exponent. If you moved it to the left, the exponent would be positive. If you moved it to the right, the exponent would be negative. For example, the area of the Atlantic Ocean is 41,080,000 square miles. It should be understood that there is a decimal point at the end of this number, so if you move that decimal point 7 places to the left, you'll have a number between 1 and 10. In scientific notation, the Atlantic Ocean is 4.1080 times 10 to the power of 7 square miles. When switching to scientific notation, double-check your work by looking back at the original number. If the number in standard notation is greater than 1, the exponent will be positive. If the number is less than 1, the exponent will be negative. Now that you understand how to express a number in scientific notation, let's look at some mathematical functions. To add in scientific notation, the exponents of the bases must be the same. If the exponents are the same, you can simply add the coefficients together to get the sum. Subtracting in scientific notation follows the same rules when exponents are the same. Find the difference between two numbers by subtracting the coefficients. When adding and subtracting numbers in scientific notation, the exponents won't always be the same. You'll need to adjust exponents by moving decimals in order to have matching exponents. The numbers in the equation shown have two different base exponents, 5 and 4. It's generally easiest to increase the smaller exponent to match the larger one. In this case, that means 2.2 times 10 to the power of 4 would become 0.22 times 10 to the power of 5. Now that the exponents match, the coefficients can easily be added together. Multiplying numbers in scientific notation is a simple two-step process. You'll multiply the coefficients and add the exponents. First, multiply the coefficients together. 3.0 times 4.0 equals 12.0. Next, add the exponents. 4 plus 6 equals 10. The result then is 12.0 times 10 to the power of 10. So it becomes 1.20 times 10 to the power of 11. The rules for dividing numbers in scientific notation are similar. You'll divide the coefficients and subtract the exponents. Congratulations! By now you have learned why scientific notation is useful, how to represent a measurement in scientific notation, how to switch between standard and scientific notation, and how to perform basic mathematical functions. Great work!